In this objective, we're going to be evaluating functions. First, we're going to be evaluating functions graphically. So let's talk about function notation. We will be using that a lot. Instead of giving you coordinates of x and y, we will be saying f of x equals y, where x is the input and y is the output, or f of x is the output. So looking at example number 1, we're going to translate this into an ordered pair and then graph it. So this states that f of negative 2 equals negative 6. So this is our x, and the output is y. As an ordered pair, you would write negative 2, negative 6. Number 2, f of 1 equals negative 2. So this would be 1, negative 2. And number 3, f of 3 equals 4. Your ordered pair is 3, 4. And f of 5 equals 6. Let's plot these onto the graph. This is my x-axis and my y-axis. So if I were to plot negative 2, negative 6, on the y-axis, I would go to the left to negative 2, and then go down to negative 6 on the y-axis. Here we go. To plot 1, negative 2, I would go to positive 1 on the x-axis and negative 2 on the y-axis. 3, 4, that's positive 3 and positive 4. And 5, 6 would be 5, 6. Now let's look at this information, but rather than on a graph, it is a set of ordered pairs. Find f of 1. Well, the point where x equals 1, the output is negative 2. So f of 1 equals negative 2. Find f of 0. So where the input is 0, the output is 8. So f of 0 equals 8. If f of x equals 3, so now it's saying when the output is 3, what is the input? We find where the y value is 3, the x value is negative 2. So in function notation, we would write that f of negative 2 equals 3. Let's look at the second set of ordered pairs. In this function, find f of 0. So when the input is 0, the output is 2. So f of 0 equals 2. If f of x equals 4, we need to find where the output is 4. The input is negative 5. So in function notation, we write that f of negative 5 equals 4. If f of x equals negative 1, the output is negative 1. That means the input was 7. So function notation, we would write f of 7 equals negative 1. Now we have points already plotted on a graph, and we need to find f of 2. So this is saying when the input is 2, what is the output? Well, that means we need to find 2 on the x-axis. That would be right here. And what lines up with that one lines up with, oops, positive 3 on the y-axis. Find f of negative 1. So when the input is negative 1, that would be here on the x-axis. That lines up with negative 2 on the y-axis. So when the input is negative 1, the output is negative 2. If f of x equals 3, that means we're going to look for positive 3 on the y-axis. That's here. And we've already identified that point. That is where x equals 2. So we've answered that in A, that f of 2 equals 3. So let's try this a different way, where you just label the points first and then answer the questions. So this is my x-axis. This is my y-axis. This point would be negative 2 for x and 5 for y. This point would be 5 for x and 2 for y. This would be 1 for x and negative 2 for y, and this last point would be negative 3 for x and negative 4 for y. So now when I answer the questions, find f of negative 3, I just look where the input is negative 3 or x is negative 3. That's this point. The output is negative 4. If f of x equals 5, find x. So now we are looking for the output of 5. The input is negative 2. So f of negative 2 equals 5. If f of x equals negative 2, find x. So where the y value is negative 2, the x value is x. Or sorry, the x value is 1. So I'm going to say that f of 1 equals negative 2. Okay, on a continuous graph, we find the points the same way. Find f of 4. So I'm going to find where x equals 4. So that is here on the x-axis, and that lines up with 1 on the y-axis. So this point right here, if the input is 4, the output is 1. Find f of 8, where x equals 8. That lines up with 3 on the y-axis. When the input is 8, the output is 3. If f of x equals 7, find x. So now I'm looking at the y-axis at 7. I'm actually at 0 for x. So x equals 0, or I can write it in function notation that f of 0 equals 7. State the domain of f of x. So this is going back into the last objective. The domain of f of x would be 0, 10. And the range of f of x would be 0, 7. Number 10, find f of 2. So I want to find where x equals 2. That would be right here. So let's go down to touch the graph, and the y value that lines up with that is positive 2. I'm sorry, the y value here is negative 3 on the y-axis. So we're looking at this point, the coordinates of that point, 2, negative 3. Find f of 1. So where x equals 1 from the x-axis, I would have to go up 2, and the y value there is 1. 1, 2. So f of 1 is 2. If f of x equals 6, so now this is giving us the y value of positive 6. The x value here is negative 1. So this is negative 1, 6. In function notation, we would say that f of negative 1 equals 6. If f of x equals 5, that would be here, and actually it crosses twice. So we have 2 points where y equals 5. Here and here. So this is negative 3, 5. And over here is negative 1, 5. So here I'm going to say that x equals negative 1 and x equals negative 3. Or in function notation, this would be f of negative 1 equals 5 and f of negative 3 equals 5. State the domain of f of x. This is going to be with arrows, so that's going to involve infinite domain. So it will go left and right forever. That's negative infinity, infinity. The range stops at 6 at the top. So I'm going to say 6. And it's going to go down forever, so that would be negative infinity. So basically, you are just finding x and y values at the indicated point on the graph. Very important that you know how to do coordinates, and if you're unsure of plotting points or finding the coordinate of points, you might want to ask me for an extra practice on that skill.